Semiconductor chips are the core component of all electronic devices, and they underpin our economy, national security, and modern way of life. That is according to the UK's National Semiconductor Strategy. Semiconductors, which are also known as microchips or chips, different names but they're all the same thing, are also listed as one of 5 critical technologies in the Department for Science, Innovation and Technology's 2023 Science and Technology Framework. And just recently, in May of 2024, the UK's Parliamentary Office of Science and Technology released a report all about semiconductors, briefing Parliament all about them and how policy might be needed in order to cover some of the vulnerabilities in their supply chain. So today we're breaking down that report to understand why are semiconductors so important, which countries are leading the way in their development, and what are the vulnerabilities in their supply chain that we need to be aware of now. Semiconductors are usually made of silicon and are used to make tiny little switches which control the flow of electricity through a larger chip. Compound semiconductors are made of a different material, gallium nitride or silicon carbide, and modern chips contain millions if not billions of transistors to store, transmit or process information. Semiconductors have widespread applications in literally every part of modern life, seen or unseen. From consumer electronics to healthcare, there are semiconductors in anything remotely smart. Your phone, your washing machine, the pacemakers that keep people with heart conditions alive. They're also going to play a critical role in emerging technologies too. Anything from AI to quantum computing to electric vehicles. The UK specifically has expertise in silicon carbide chips, which can be used to make lighter and more efficient electric vehicles. Countries all over the globe, though, are racing to become leaders in semiconductor design and manufacturing. As it stands, though, there are real niches in the market. For example, one company, ASML, based in the Netherlands, produces 100% of a specialized piece of chip manufacturing equipment. Meanwhile, 75% of the actual manufacturing is done in China, Taiwan, and Japan. The USA leads the charge overall in chip and software design, whilst East Asian countries lead in manufacturing, particularly South Korea and Japan. The raw materials for manufacturing are sourced from all over the world, but the packaging and assembly is also mainly in East Asia. This perhaps due to it being highly labour intensive, as well as a lower skill and capital role. So where does the UK fit within this hodgepodge of different sectors and competing countries? According to the National Semiconductor Strategy, the UK has strengths in research and development, R&D, chip design, intellectual property, and compound semiconductors. There are 25 UK facilities producing specialised compound chips, but none that are capable of producing the most advanced semiconductors. Looking wider though, if every country differs in its production and its manufacturing, and if the raw materials are sourced from all over the globe and cross borders to be used, how does the supply chain for the production of semiconductor chips end up looking? Complex. According to Accenture, the constituent parts of semiconductor chips cross roughly 70 international borders before final construction. Now, the US semiconductor industry actually says that this geographic location is a positive thing, as it encourages innovation, competition, productivity, and cost savings. On the other side of things, though, some stakeholders from across the industry say that the global infrastructure is a system that is still too vulnerable to natural disasters, global conflicts, and infrastructure failures. Sure, the industry attempts to preempt future problems and future demand, but its behemoth size makes it hard to accurately anticipate and respond to issues. The pandemic is an example of one of these unforeseen problems. COVID led to massive fluctuations in the demand for semiconductor chips. Remote working flourished, leading to an increased demand for electronics like laptops, making these goods harder to obtain. Meanwhile, demand for vehicles decreased, so chip manufacturers scaled back, but when everything opened up again, they then couldn't keep pace with rising demand. Multiple reports estimate that in 2021, over 9.5 million vehicles were removed from production, and the automotive industry lost $200 billion globally due to shortages in semiconductor chips. There are, of course, other factors that can affect supply chains. Natural and artificial disasters are rare but dangerous. Semico research highlights that 61% of manufacturing facilities are in high-risk areas from earthquakes, such as lots of areas in Japan. Geopolitical conflicts could pose a major threat to production too. The Taiwan Semiconductor Manufacturing Company, TSMC, produces 90% of the world's chips. However, it is also described by think tanks as the most critical single point of failure in the supply chain. This being due to the political problems that the state has with the People's Republic of China, who considers Taiwan to be a breakaway state. Therefore, there is a consistent threat of military interventions there. So, there are serious geographic dislocations and flaws within the global supply chain. The necessity to acquire parts from all across the globe and combine them with cheap labour perhaps extends the supply chain to longer than might otherwise be necessary. But what are the solutions to these vulnerabilities, and how do governments prevent perceived threats? In May of 2023, the UK government published the National Semiconductor Strategy. This strategy aims to focus on the UK's strengths in R&D, design and IP, and compound semiconductors. There are set to be £200 million in investment between 2023 to 2025, and £1 billion in investment over the next decade. There are two main areas that the UK can focus on to decrease the vulnerability of its supply chain. First being building on existing expertise, and the second is building onshore manufacturing capacity. Unlike the USA and EU, the UK still relies heavily on Taiwan for importing and producing advanced semiconductor chips. Making parts of the supply chain local to the UK to reduce foreign dependence in a process known as onshoring would mean that the UK can secure its own supply chain in a more fulfilled way, reducing dependence on foreign nations and companies, and shielding themselves in a way from the risks that those foreign nations and companies might be exposed to. The obvious challenges to this onshoring process, though, are cost, as well as labour and supply shortages. For example, building an advanced silicon plant takes years, with costs for that being quoted between $10 to $28 billion. Furthermore, some critics within the industry have suggested that just building the manufacturing plants in the UK won't be enough to secure the supply chain, as parts may still have to be shipped off to East Asia for assembly, testing, and packaging. They suggest that countries like the UK should instead spend their efforts on screening more effectively for malicious hardware. Now, instead of onshoring everything, another way to increase and secure the supply chain would be to collaborate with trusted partners. And the UK is doing this. In March of 2023, the UK formed the UK-Japan Semiconductor Partnership. A year later, in March 2024, the UK joined the EU's CHIPS Joint Undertaking, granting businesses and scientists within the UK access to up to €1.3 billion of research funding. These are all great steps, but looking across the entire supply chain, the problems are large in magnitude, sometimes exceeding a national scale. So, as much as you can onshore some of the processes and build on your existing expertise, there is much else that you can do past that. The supply chain is too large and too convoluted to be overhauled, at least overhauled effectively. And the manufacturing process too has too many pieces and steps to be effectively moved to one country. All in all, semiconductors are essential to all the new forms of technology being developed at the moment. The industry is massive and growing in size, but also very high cost, with advanced engineering costs rising 18-fold between 2006 and 2020. The supply chain and development process is flawed, and risks in the long term having more and more shortages and delays if the world situation becomes more precarious. For now though, as we come to the end of this video, which I've shot on a digital camera, will edit on a laptop, and you'll probably watch on your phone, think about all that has gone into that technology. Think about how many international borders have been crossed by those tiny but integral chips. Isn't it incredible how much those tiny pieces of silicon can accomplish? Thanks for watching this episode of Science Fairs. If you found it interesting, then be sure to leave a like, and if you want to see more, then be sure to subscribe with notifications on so you don't miss a video. We hope to see you in the next one.